Welcome, everybody, to the Good Data Podcast. We have a great show for you today. It's episode 5 of our Green series, and today we're going to talk about the current state of green energy in the United States and how data centers fit into that. Because there really is a ecology of different influences on the total carbon output of the world right now. And data centers are playing a bigger and bigger role within that ecosystem. And I want to take ownership of that as an industry and realize how much of an effect we as data center designers, owners, operators are actually influencing the world right now. And how I don't think there is enough understanding of that place. So, to that end, we're going to talk a little bit about the green energy and a little bit about how we can influence the minds and hearts of those who are in our industry to bring about some sort of a sea change to move from increasing the carbon footprint of data centers on a geometric level to maybe evening out at some point, just having some sort of end goal for when data will no longer consume the world. Let's go! So I started thinking about this topic so long ago. I started to realize that whenever something is increasing at a geometric rate or quadratic rate, whatever the effect of the increase is, even if it's a linear rate, it has to stop sometime. So the question is when? At what point will the data center industry have to make the other side of the S-curve and stop growing and finding a level that makes sense for the world? And I think it doesn't look like it's anytime soon. We have 100 megawatts per year being turned up in Ashburn, Virginia, and we have hundreds of megawatts in Dallas and in New Jersey. And the pace appears to be increasing. And then you can add crypto mining into that. And even though that was a blip, it still is something that came out of nowhere and suddenly added millions of megawatt hours to the total consumption of energy in the world and the United States. It's hard to imagine how we got here. How going from ENIAC, or even before that, mechanical computers, and how we moved in the course of less than 100 years to taking up 5% or approaching 5% of the total global energy, and seeing that on a course to increase to 20% by some estimates. I think the estimate was by 2030 or something. How does that make sense? How can that be sustainable? It is by definition not sustainable. There is going to be a point when not all of the world's energies can go to powering computers. So, as much as I want to see growth in the industry, and as much as I want to see the continuation of the good ride that has been going on, I think we all have to see that, first of all, floor space is not the limiting factor, that the high density revolution has really happened, and 30 kW racks are normal now, and 50 kW rack HPC clusters are around. I've seen a bunch of them. It's a continuation of a number of trends, but an acceleration of those trends. And containerization, HPC, any type of high-density virtualization, it's all accelerated that ability to cram more into less, to put more kW into less, to still use the same amount of power, but use it in a different way. And people like to bring up Internet of Things or the proliferation of social media as the drivers of this. But my understanding personally is that you say analytics, that it's analytics that's taking it up, but what people mean for the most part of analytics is taking human behavior and running it through an algorithm and trying to figure out how to sell or monetize or create value out of a human being. That that term analytics is a term that could be adjusted to say manipulation. That you could also say, oh, we're getting the best products to our customers. But I want to take it a step further and say, well, that analytics is the act of turning computation into insight. And it's a very difficult thing to do, but it's being used mostly to sell more stuff, to get more services into people's lives. And it's being done effectively, but there's an endpoint to that. And one of the endpoints that we're running into is that so much of it is business to business, that the consumer demand is fine, but there's so much difficulty in selling to normal people that so much of what is sold and what makes money being sold is luxury of some sort or another. And so my question is, what good is all of that energy being put to? I'm not saying that it's inherently bad for people to have luxury items. I'm not saying that it is evil to try to understand human behavior and deliver good products to people. But there is a potential for evil that I think has been crossed many, many times. And there is a potential for good and positivity that has not been taken. And that is incredibly disturbing. The idea that we have machines capable of so much wonder and, I'll say, beauty. You look at some of the AI-generated art that has started to happen. What is it called? ThisIsNotAperson.com. Go to that. It is an incredible collection of images that were generated by neural nets that look 100% like real people, that you would think this is an actual human being, but it is actually just an amalgamation of many different images of people that was somehow turned into an image that looks very realistic. It's what the computer thinks people look like. And that type of generative neural network is going to become more and more apt at creating things, which means that human creators, can leverage them and use them in their creations to create more lifelike, more believable, more beautiful, let's say, versions of video games or versions of animations or who knows what art or product or solution those will bring. And I think that can be wonderful. But that is such a tiny piece of what all of that analytic software is being used for. Much more of it is trying to parse the text of people's Twitter feeds or their Facebook posts to figure out, by whatever similarities there are between the semiotic concerns of one person to another, figuring out how that creates a bond between those two people. Like you may not even realize the ways that the way you talk, the way you think actually informs what you buy, and how that information can then be used in a way to get you to buy more and get you to feel FOMO and get you to want to be on that system, whatever it is. The economy of eyeballs is a very worrisome economy because it incentivizes people to be glued to their phones and to their laptop screens. And I think all of us know that is not what makes us happy. And yet, that quote-unquote analytics, that quote-unquote neural engine that drives the entire world into a collective database that can pick apart all of our desires and similarities. That is something that is not for the good and has definitely been used for the evil. And it is powered by us, by we in the tech field. And as much as data centers are not the ones who are driving that demand, the demand is coming to data centers aren't creating the demand, as much as you can feel as though, as a data center operator, you are not in charge of the software that is run within your data center. It's very true. And in some ways, it's very ethical to say that. However, you must know that the incredible effort that you have put into powering this worldwide, immaculate, beautiful web of computers and networks and interconnections is being used for something often very foul. And I just ask, is that something we want to enable? If we are, as data center operators, the body of the internet, and the software that runs is the mind, then we are part of that thing, and we are inextricably linked. As much as we don't have power to make that mind better, we at least can feed it well. We can try to make it something that can be sustained so that we don't continue to grow exponentially and exponentially and exponentially. That we can turn that S-curve and find some other way to monetize than just throwing megawatts into the ether. And maybe find ways to become part of the global electrical system. There's definitely opportunities there. I think the Tesla batteries that exist on a utility scale can be used to link data centers into the grid to create demand shaving and to also add reliability to data centers. I'll throw out Bloom Energy. That's there. The models for that, they're not big enough to make a difference for hyperscalers. It would need to scale so much for it to really make sense. But it's so possible. The technology is there. The environment is there. But even those technologies don't solve all the problems. 2018 increased the carbon emissions for the United States the most since the economic downturn in 2008. And some of that was due to us data center people, bringing more online. And that was because there was demand. And it's hard, what would have happened had we not turned that up? Really, it's easy to have plausible deniability about having any part in that. But I just want to encourage everybody to really, really think about green data centers and what that plays in taking what is an unsustainable path and turning it into something that our children and our grandchildren can be very proud of. On that note, thank you all for listening. I am so thankful to be doing this podcast and for being able to say what I want to say and for not being censored. And I am so thankful to anybody who is crazy enough to listen to me, especially these episodes where I am on my own. I am astonished that you are listening, and I am so thankful for you. And I cannot wait for some of our upcoming interviews, which I think are what people really come here for. And I would just so love to be able to really interview all the amazing people in the data center space that I have met, because there are some intelligent, fascinating, just lovely people who belong out there in the conversation of the world. And that's my goal. Let's make this happen. All right, everybody. Be good. And we'll talk to you next time on the podcast.